Hopefully paint tools don't give me immediate issues, immediately crashes. Rip my stream indeed. Ay, ay, ay. Okay. Well, here's what's gonna happen. I think it's pretty clear, everybody, that we've tried to use the 3D paint tool, and yeah, it's just not happening. So it wants to interfere with Streamlabs. I said, okay, you want to interfere with Streamlabs? Be my guest. Interfere with Streamlabs. Guess you'll have to. Guess we'll just have to run this. All right, that's perfectly fine. Windows updates makes me sad like bananas. All right. In any case, let's give some other things a try here. Let me actually shut down a couple things that relieves some pressure off of my thing. All right. Check something. Okay. All right. I need to think of a few weeks here. Maybe I should just project that. Signs stuff there. All right. All right. I guess we'll have to go with it for right now. All right. In any case, let me move forward. All right. So, what are some standard equations of an ellipse? All right. So there's going to be two standard equations of an ellipse. All right. All right. So we're going to have two specific forms here. We have x minus h squared over a squared plus y minus k squared over b squared equals 1. And we have x minus h quantity squared over b squared plus y minus k squared over a squared equals 1. All right, now each of these has their own properties associated with it. So I put it in a nice little handy table for you to go ahead and look at. And I do need to show off one thing here on the paint tool, of course, besides problems, for us to go ahead and go over. All right, so number one, what are the standard equation? Number one here with this table here, what's the general shape, right? Because what we have here is, let's take a look at the first one here. We have, again, x minus h squared over a squared plus y minus k squared over b squared equals 1. Now, what we have here associated with each one of these ellipses is we have a center of this ellipse, which is going to be h comma k. By the way, in regards to h comma k, one thing to keep in mind is that notice that h comma k is always opposite of what is written. Okay, so I guess I put that as a little note here as well. Note, the center h comma k is always opposite of what is written. All right, so don't fall into the trap. Don't fall into that trap about h comma k there. About you see minus h and minus k and just assume that it's just that. Nope, it's always the opposite of what is written. We are also going to have a major and minor axis. Hey, all right, what are we doing? We're doing conic sections. Hey, Dylan. Dylan, my dude. Dylan subscribed? Jeez. Dylan, thank you so much for the sub. Man, thank you so much, my man. How are you? I hope you're doing well. Thank you. Thank you so very much. That's really super kind of you, man. Really super kind. I don't deserve subs, but thank you so much. It's really kind of you. Okay. So we're going to have a major axis and a minor axis. I'm good, my friend. Now, with the major axis, we're going to have major vertices. On the minor axis, we're going to have minor vertices. So I want to take a look here at the first picture. So on the first picture here, what we're going to have is, what's the x major axis mean? What is that picture going to look like? If we have a major axis of the x-axis here, this is what the ellipse is going to generically look like. It's going to look like this. Okay? If we have the y-axis case, okay, let's say we have the y-axis here. All right. Then this is what the ellipse is going to look like. Again, at the end of the day, where is this going to, where these major and minor vertices are going to occur? Again, if it's on the x-axis, the major vertices will be on this elongated point here. They'll be over here and over here. And the major axes here, put in red, will be here and here for the ellipses that's on the major axis of the y-axis. So that's why I kind of split this up. I said, well, what's the major axis? What's the minor axis? What are my major vertices, which is with these points in red, and what are the minor vertices? Now, one of the things that I don't like what the book does specifically here is it does not, for some reason, the book does not talk about minor vertices, but it absolutely needs to, considering the fact that you do need these 2 points here in order to map out the ellipse appropriately, okay? Because if you don't have those, then there's no way you can actually graph them. For whatever reason, the book just kind of skirts the topic very, very lightly. But I want to put it prominently here in this table, so at least you have the resource available to you in order to go ahead and do this a whole lot quicker. Now, how do you determine your major and minor vertices? Well, that comes from the form in the function here. What it depends upon is it depends on where this a and b are located. So notice this first one here has a squared underneath and b squared underneath the y. This second one here has b squared underneath the x and a squared underneath the y. One of the things that's always true here that is very, very important is this little important note I put here. A is always going to be bigger than B. This is always going to be true, okay? So you need to be very, very aware of that. A is always going to be bigger than B. So we're going to have one number squared, and we're going to have another number squared, and one's going to be bigger than the other here in order to do this ellipse. Now, before you ask, there will be at no point where A is going to be equal to B, okay? So they'll never be equal to each other. It will always be, they'll always be different numbers. Okay, so I'm just going to point that out right now before you go ahead and ask. I get that question quite a bit. So, all right. So having said that here, what does that mean? Well, let's take a look here and how we can graph these ellipses and also find another key piece of information which we'll talk about here in just a second. So, all right. We're going to try and find this foci here, but I want to talk about the foci here at the end of our example here when we're going to go ahead and do this graph of an ellipse, okay? Because what I want you to see first here specifically is I want you to go ahead and see an example of this first, and I want you to see like what the standard form kind of looks like, and then we're going to kind of just work our way up from there. See how we can work with other examples. So let's go with something easy to start with, and then let's see what we get for later stuff. So, all right. Okay, so let's go over this here. Let's just start off with something super basic. All right, something really, really super basic, and then we'll work our way up. All right, so I'm gonna go up here for a second. All right, so here is our example. Okay, notice that it's always plus in the middle, and it always equals 1. That's the standard form of an ellipse. All right, so that's pretty common. Now, the real question behind this is, okay, well, if this is what we have here, let's go through the steps on how we can identify each important part. Okay. So let's go to step 1. Step 1 says, first write the equation into standard form by factoring, dividing, completing the square. And there's going to be various ways for us to go ahead and put stuff into standard form. Now, we already have it in standard form here, at least to start off with in this problem. So we're already done here for that part. I always have a tough time with it. Can't see stuff. My eyes so bad. All right, so this part here at least is done. All right. All right, let's do step number 2 here. Now, I want you guys to take a look at this problem here very carefully. We need to find the center of this particular problem here. We need to find the center. All right. What is the center of this ellipse? What is the center of this ellipse according to what we have here in our equation? What do you guys think? What is the center of this ellipse? Brian says x squared y squared. Now that's not exactly correct here, Brian. Remember, take a look. It would be the numbers next to x squared and y squared. And it wouldn't be squared either. It's not the letters that you should be looking at. It'd be the numbers next to those letters there, Brian. Is there a -1 here? What's another way? So let's think about it this way. Okay, good. Okay, so remember, not 1 either. Not -1. Not 1 and 1 either. All right, this is why I have to ask the question here, because you guys got to recognize this. Another way to write x squared, remember, is writing it as x minus 0 squared. Okay, you could write y squared here as y minus 0 squared. That's a little conceptual question I ask here. So Nicholas has the right of it here. The two numbers here that would represent the center of this ellipse would be 0, 0. Okay? Just going to point that out here. Be like, all right, well, remember, you can always rewrite it a different way if you just use 0. Remember, 0 doesn't effectively do anything, but it is important, at least in this situation, where we can establish the center of our ellipse. All right. All right. Good stuff. All right. Now, are there any questions about that? Oh, I guess I did this out of order. I'll do this in a second. Any questions so far? Nope. All right. Okay. Now, let's look at the next part here. That is fairly important. All right. So the next part here is I want to focus on identifying A and B. Now you're probably saying A and B. Well, how do I know what A and B is going to be? Well, this case I will show you here. I'll showcase how to do this particular part. What I'm going to do here is, order for us to identify A and B, I'm going to literally rewrite the problem here one more time. I can rewrite it as, say, x squared over, and I notice it says 16, right? So I'm like, okay, well, here I have 4 squared. That's what 16 is. And I have y squared here as 2 squared. Okay. So I need to identify my A and B. Now, to identify my A and B here, remember, the note says that A is always bigger than B. So A is going to be the bigger number, and B is going to be the smaller number. That's always how it's going to be, no matter what. All right, for these parts, it's always going to be the same. So A being the bigger number is 4, and B being the smaller number is going to be 2. Okay, so A is 4, and B is 2. Okay, so that part there isn't too bad. You just need to be able to rewrite it in such a way where you can easily identify A and B, and you're not going to have any issues with that whatsoever. Okay. All right. So let's move to step 4 here. Step 4 says identify the major and minor axes. Now, I always ask you to identify the major and minor axes so that way you have a clear picture in your mind about what the expected answer is going to be at the end of the problem. All right, so let's identify the major and minor axes here. All right, and it's actually easier than you think. So what's the major axis here? The major axis will always be the letter of which A is underneath. Essentially, look for the bigger of the two numbers. Whatever letter that bigger of the two numbers is underneath, that's going to be your major axis. That's the easiest way to think about it. Bigger number on bottom, underneath which letter? Is it underneath X? Is it underneath Y? Okay, well that letter is going to be your major axis. Okay, I'm just going to simplify it as best as that. So if I looked at this problem here, what's your major axis? Is it going to be the x-axis or is it going to be the y-axis? Will it be the x-axis or will it be the y-axis? Yeah, right? Yeah, definitely. That's correct. All right, so the answer is definitely the x-axis. Okay, I completely agree. 16 is underneath the x. All right, so that's our major axis. Perfect. All right, easy peasy lemon squeezy. All right, that means by default here, our minor axis here, as a result, is going to be our y-axis. All right, since that's just its respective counterpart problem. Okay, easy enough. All right, so by process elimination, we have that good to go. All right, good stuff. Let's move forward. All right, let's go to step 5. All right, next step here is to find the major and minor vertices. Okay, now the major and minor vertices are dependent on what your major and minor axes are. Now you notice here are the major and minor vertices here put into our little equation, okay? But the way you want to kind of think about it is this is where A and B is actually factored in. So for example, in our case, our major axis is X and our minor axis is Y. So for our major vertices, we're going to take our X value and we're just going to go left to right by, in this case, the A amount of units that we have here. You're probably saying, and for the minor vertices, we take our Y value, go up and down by B units in that instance. Now, admittingly, you're like, that's a lot of letters that I kind of have to look at. So maybe what would be helpful for you here, and again, I'm going to put this full screen here. What may be helpful for you here for step number 5, have space there, question. I'll put this over here. All right. So because our major axis is the x-axis, you can imagine a shape that looks like this, right? Your major axis is going to be on the x-axis here. So again, you're going left and right on the x-axis. So this is going left and right, for example. So here you're going to add by a unit since that's your major axis in that case. So let's talk about our major vertices. I'm going to start from the center, okay? I'm going to go 0, and I'm going to go 0 minus 4. Again, that's A, comma, 0. All right? And 0 plus 4, comma, 0. Again, because that is along the x-axis there. So I have to add and subtract A to the x coordinate. Okay? And then so the 2 points I'll get here, obviously, is going to be negative 4, comma, 0. and 4 comma 0. And now we repeat this process here, but this time with the minor axis. This is why we I got the 4 from the A. Yes, exactly. Right, so to get your major and minor vertices, we do need to use this A and B here. That's why we identify it here in step 3. So understand that I am putting the pieces here together, Brian. I need to identify the A and B in step 3, and then I need to identify the major and minor axes. Because in this manner, the reason why I do that there specifically is because it reduces the amount of confusion to find my major and minor vertices that you see here in the next step over. So it's like, if, okay, I see that my major axis is the x-axis, so I know I'm going to add and subtract A from my x coordinate, okay? I know I'm going to add and subtract B from my y coordinate, okay, of my center. Because that's essentially what we're going to be doing. So it reduces the amount of confusion. You have the information in front of you, and you'll know exactly what to do here in this next step, in step 5. So there is a specific, like I said, there's always a reason why I choose to do something. That's my reason why I'm doing it in that manner. I just, again, the one thing I want to do and want to make sure that everybody understands is that I just want to avoid guessing altogether, right? I don't want any guessing. Guessing's the last thing that we want. So reduce the amount of guessing. I'm gonna have it that way. All right. Get 0 comma. Let's see here. So get 0 comma 0 minus 2, because this is our minor vertices. 0 comma 0 plus 2. Again, this plus 2 and minus 2 comes from B, which was equal to 2 here, and that being along our minor axis. We get 0 comma minus 2 and 0 comma positive. Okay? Alright, so before I move any further here, are there any questions about that? Any questions at all? About our major, minor vertices, any questions? I want to be sure that this is crystal clear about where this is coming from. It is not coming from out of nowhere, right? I am deliberately picking this on purpose, and I'm doing it in a specific manner. Okay. So I'm going to move to the next part here, if there are no questions. Okay, let's move to step 6. Now, step 6 is actually graphing the thing. So let's graph the thing here, and then we'll have one more thing we'll need to talk about. So let's put it on a graph. We actually have points, so let's put it together. We have our center here of 0, 0. But again, using their center here, we're just going to go 1, 2. All right. Put these points down here. Our major axis here, we have 4 comma 0. We have negative 4 comma 0. We have 0 comma minus 2. We have 0 comma 2. And now we just go ahead and connect the dots here into nice oval-ish type of shape. All right, and there we go. We have ourselves a winner. Good. There is our ellipse as a graph. All right, it's missing a couple, maybe one more thing, but all right. So putting the pieces together isn't too hard once you have all the information in front of you. Now, we are missing one more part of the puzzle here, so I do need to discuss about that right now. All right, so what is that part of the puzzle that we're missing here? Well, it's an extra piece of information. That is this last step. There's this last step here, which is step 7. If I was saying, well, wait a second here. We went ahead and we wanted to graph stuff out, and we already have a graph. So it's like, well, what the heck are we doing? Why are we moving forward? Why are we trying to find one more thing? Well, there is one more key piece of information that you need to find in every ellipse, and that is in reference to the second question on the handout. And I'll come back to the paint here in just a second. But that talks about the foci for the ellipse. Okay. So the foci here of the ellipse is going to be, again, there's 2 points on the ellipse that are basically what we call the foci. Now, what's important about the foci here is that the foci are located on the major axis of the ellipse. Okay, those are always on the major axis of the ellipse. And one other thing before we get to the formula here, for just an example here, the foci here are always on the inside of the ellipse. Okay, so the foci here, never on the outside, but on the inside of the ellipse. Okay, so if you get points that are outside of the ellipse, you know you went wrong somewhere with your calculations. All right, so the real question is, how do we find this foci? Well, this foci here, and I guess, let me think. Maybe I need to add something to it. So probably I do. So let's talk about the foci here for a moment. The foci here are located on the major axis ellipse, and we have this c squared is equal to a squared minus b squared. Essentially, if I were to edit this just one more time, math tool. Bring up math type first. Okay. What you can also conclude is that c squared is equal to the square root of a squared minus b squared. So I guess I should have put that down. So the basis, I wrote down the basis of it, but I didn't actually write down the actual other. So let's say we have c squared is equal to a squared minus b squared. And what you do with this c here specifically is you add or subtract that c from whatever your coordinate is of your major axis. Okay, so I'm going to take this a squared minus b squared, whatever it may be, okay, and we're going to add and subtract it by that major axis starting from the center, of course. So how does that work? Let's find out. All right, so let's find out how it works in our example. In our example, all right, back to our example here. We have a squared minus b squared. Again, a squared here would be 4 squared. Okay, so let's do this out here. So we have c is equal to the square root of a squared minus b squared. Okay. So c is equal to the square root of 4 squared That's not the best. Imagine this is 4 instead. It looks like 14. All right. Minus 2 squared. All right, so here we have the 16 minus 4, all right, which is the square root of 12. Square root of 12 can be broken down into 2 square root of 3. Okay, so that's how we get square root of 12. And so all we have to do with 2 square root of 3 here, since that's going to be our c, is we're going to add and subtract 2 square root of 3, okay? And we're going to add and subtract that to the x coordinate. Now, the reason why we're doing the x coordinate here is because that is the major axis that we identified here back in step 4. So if we do that here specifically, our foci here are going to be 0 minus 2 square root of 3, comma 0. and 0 plus 2 square root of 3, comma 0. So that's just going to net us here negative 2 root 3, 2 there. Okay. Alright, comma 0. Alright, so this is what we have here. Foci here, again, negative 2 root 3 comma 0 and 2 root 3 comma 0. Now, if you did 2 root 3 on the calculator here really quick, I'm just going to look up the decimal equivalent for that. So 2 root 3 here is approximately 3.46, thereabouts. So, plus or minus like 3.46 for example here. So if you were to put it on a graph, right, and obviously decimals, if you're doing it by hand, is kind of hard to do. But like 3.46 is like right here, like minus 3.46 and positive 3.46. You'll notice that where these are located are, again, inside the ellipse, okay? So that's the part I wanted to kind of show off there. Like, okay, well, what's the important part? Well, all right, well, the most important part here is that these foci here, these 2 points, are located on the inside of the ellipse. All right, and that's exactly where they need to be for any one of these problems that we're doing. Again, if these 2 points here, for whatever reason, are outside of your ellipse, went wrong somewhere. Doesn't need to. That's not happening. All right, so I just want to point that out here. Be like, oh, where did this come from? Like, oh, okay, I understand. All right. Any questions about this example here? We're going to move to a more complicated example here next. Maybe not super complicated, but still one that bears doing. So, but first one, books. Any questions? I hope everybody's okay so far. Hope everybody's not super overwhelmed. Trying our best here. So. No? Okay. All right. Okay. Let's look at the next one. Okay. Hopefully everybody has this example down. I'll move on to the next problem here. All right. Let's move that out of existence, and let's move on to the. All right. Sure. All right. Next. All right. Yeah, let's do that one. All right. So I want to do a slightly more complex one here. It's not, again, just easing into this process here. Okay, so here I get 9 times x minus 1 squared plus 4 times y plus 3 squared is equal to 36. Okay, so this is our next example here. Again, we're going to want to graph this, find the foci, do all those sort of guys, okay, do all sort of things. Fine. All right, that's what we want to do. Now, let's talk about what we need to do first here in this problem. All right, let's go back to our standard form here, our little table that we had here to start with. All right, so this is the equation that we start with here. All right, this 9x squared stuff. All right, fine, seems fair. All right, so can you tell me here, what do you think I need to do first here? What do you think needs to happen here first? I want to get your opinion about this. What are you, looking at this equation here that we need to work with, what do you think needs to happen here? You know, there's one glaring thing. Can I put the 9 and 4 under? I can get 9 and 4 on the bottom? Okay. How do I do that? I can't magically just move 9 and 4 on the bottom. I have 9 times something. I have 4 times something. That's nice. But I divide? Divide by what? I don't know what. Divide by 9, divide by 4? I don't think that's how algebra works, gentlemen. Algebra doesn't allow you to do that. You can't divide by 9 and then magically divide by 4. And then hope to get it to work out. Subtract 4? I don't think you can subtract 4 when it's being multiplied. 36 divided by 9? So just 36 divided by 9. So just divide by 9? If I again, with algebra, ladies and gentlemen, I can't pick and choose. Remember, it has to be everything, all or nothing, right? If I divide by 9, I have to divide by 9 everywhere, right? That's what I have to do. I can't be like, oh yeah, I can divide one thing by 9 and then magically I get what I want. Like, I wish I could do that, but I'm not allowed to do that. So, again, it's always a balancing act. But you guys have some good ideas. You guys have some good ideas. You guys are hovering around what I would love. Could you show the steps again? Well, I will show the steps here, Fritz, but I know I'm being a little evasive here, mind you. Group it. Now, the reason why I'm being a little evasive here, Fritz, is because of the fact that I want you to take a look at the table there. I want you to notice something here that's required for problems like these. What do you notice here about the form of the equation? You have to do something with the 36? Aha, you see? Yes, I know. Again, doing it on purpose, but we do something with the 36. Well, what do we got to do with the 36 there, Nicholas? Okay, I like the ideas. You're getting there. What do I gotta have? What has to be required there on that? Take a look at the sides of the equation, maybe. Oh, has to be 1. Okay. All right. Yes, that's right. All right. Brian says divide 36 across. Okay. So notice on the right-hand side, right, it says it has to equal 1. All right, without question, it has to equal 1. Right, divide by 36. That's exactly right, Fritz. So exactly what Brian said, yeah. Divide by 9 first and then divide by 4. Ooh, no. No, Khadija, no. What we want here, don't want to do that. What we want to look at is, when we look at the form in the table, we want this to equal 1 at the end of the day. What we have on the right-hand side is we have a 36. So, okay, I don't want that 36 to be there, right? I don't want that. And I can't subtract by 30. I don't want 30. If I subtract by 36, Jess, then the problem is I'm going to have 0. Instead, what I can do is I can divide by 36. And then I make sure that for a certainty, I'm going to have a 1 on the right-hand side, okay? So I just want you to see, be like, what's the basis of my reasoning here? My reasoning is I want to make sure I have a 1 on the right-hand side, and then I hopefully will have stuff cancel out here with this 9 and the 4, then we could get it into a nicer format. Okay. let's take a look at what happens when we divide by 36 in this instance, okay? So, this is what I want it something plus something is equal to 1. That's what I want. So, I get 9 over 36. So, in this case, if I rewrite this, I'm still in kind of the step 1 kind of phase here. So, haven't gone anywhere yet. I have x minus 1 squared. 9 over 36. 9 goes into 36 4 times. So, I get a 4 here. Plus y plus 3 quantity squared. 4 goes into 36 9 times. And that equals 1. Okay. There we go. All right. So everybody see where we came up with that, right? Everybody see like, oh, okay, that that wasn't, I promise you that wasn't magic. Like, okay, there it is. All right, not bad. Okay, so far so good, right? So far so good. Okay, now we have it in the form that we want. Okay, so let's at least have that. We have it in the form that we want. Right? That's what we have. Now let's go through the steps here. Let's go through the steps. I have it equal to 1. I don't have any coefficients on the numerator, which is fine. There's ways you can handle that, but not going to handle that right now. Not on this problem, anyway. Let's go to step 2. Step 2 is to identify the center. Okay, so step 1 here is the toughest part, just making sure that you do the right thing. All right, Brian says the major is y. I agree. But let's find the center first. And we gotta find a couple things before we identify the major axis. So working a little bit ahead there. Let's just find those key pieces first there, Brian, and then we'll write down the major axis and minor axis. So what is the center here in this case? Let's expand on this here. What is the center here in this instance? What's the center for this ellipse? What do you guys think? 1 and -3. All right. All right. That is correct. Okay, so 1, comma, -3 is correct. All right. Very good. Very good. All right. You guys are absolutely right. Okay, so again, the opposite numbers than what were shown, right? So we have -1, so it should be opposite, should be +1. Here we have +3, should be opposite, should be -3. Okay, so so far so good on that front. Okay, that sounds absolutely fantastic. Okay, good job. All right, so I agree with what we're doing here so far. Okay, good. Good stuff. All right. So before I move forward here, excuse me. Before I move forward here, are there any questions? Any questions you guys have? All right. Nope. All right. Good stuff. All right. Let's identify step 3. All right. Step 3 is to identify A and B. All right. So if we're going to identify A and B, again, just rewrite your problem here. So you have x minus 1 squared. A is 3 and B is 2. That is correct. Good. So you'll have 2 squared here. And then you'll have plus y plus 3. 3 squared, which is over 3 squared. remember, all you have to do is take the square root of the number on the bottom here, okay? So whatever that number is going to be, okay, you take the square root of that, number there, and then you should be good to go. All right? I'm just pointing that out there. All right. So A is let's see here. A is 3 and sorry. I had to edit something. It's 3. Put a little box around that so we know that to come back to that. All right. Good stuff. So far so good. Okay. Let's also identify our major and minor axes. All right. So again, now that we've identified the center and we have identified A and B here, we need to find our major and minor axes. All right. And so once again here, what was our major axis again? What was that again? What was our major axis? Major axis here. So our major axis here is going to be the y-axis. Okay, again, because A here, the bigger of the two numbers, is underneath y. Because that's underneath y, let's say that's the major axis there. All right. And so we have the minor axis here is the x-axis. All right. So again, just by default, there you go. All right. So far, so good. All right. Okay, next we're going to take the major and minor vertices. Okay, so let's find our major and minor vertices. So again, for these two parts here, especially for the major and minor vertices, especially for these two parts, take these really slow so that way you get the correct calculations moving forward. Okay, remember that you're going to start from your center here. Okay, our A here is 3. Now in our, well, let's go back to our little table here before we actually do this out. Notice that if you have your major axis as the y-axis, oh, that is correctly. We're going to add and subtract a from the y-coordinate. Okay, we're going to add and subtract a from the y-coordinate there. All right, so again, this is why we write down the information beforehand, so we know exactly what we're going to be adding and subtracting and from which coordinate. From the y-axis being the major axis, we're going to add and subtract 3 from that y-coordinate starting from the center. We're going to have 1, comma, minus 3 plus 3. We're going to have 1, comma, minus 3 plus, oh, not plus, minus 3. Sorry. Why did I put plus? Sorry, my bad. Your minus 3 there. All right. So here I'm going to get 1, comma, 0. And here I get 1, comma, minus 6. All right. So before I move forward here with the minor vertices, are there any questions about these major vertices? Like, does everybody understand where these numbers, like why I'm adding it to the y coordinate here, and why this is happening in this manner? Want to be sure that this is crystal clear about why it's now going the other way compared to the first example. That's kind of like the important part here. Can I show on where on step 1 you found that? I found what? Where I found Where I found 1 comma minus 3 as the center? Is that I apologize if I'm not sure about the question there, Brian. I want to be able to answer it. I'm just confused. Yeah, so this was the problem that was given, right? So the problem that was given was 9 times x minus 1 squared plus 4 times y plus 3 squared equals 36. That was the problem that was given. Okay? The way I set it up is that I had to divide by everywhere by 36. The reason why I had to divide everywhere by 36 there, Brian, is because in the form of the equation, I have to have it equal to 1. Okay? So I need to divide everything by 36 to ensure that the right side there is equal to 1. And then I take a look at the results of what happens afterwards. So then I have 9 over 36 here, 4 over 36, and that's where I got the 4 and the 9 from in step 1. Oh, you're talking about, okay. All right. If you're talking that part, so understand what the major axis is. So there's a purpose, like I said. In step 2, you identify the center. In step 3, you identify what A and B are. And in step 4, you identify the major and minor axes. All those 3 pieces put together, Brian, determine how you do step 5, which is your major vertices. If you've identified your major axis there as the y-axis, you know for a fact that the shape of the graph here, just the generic shape, is going to look like this. This is what the shape of the graph is going to look like. It's going to look like that. Okay? Because you know it's going to look like that, your major vertices here are going to go up and down. Right? Oh, let me move my cam out of the way for this one. Okay, so you know that this is going to go up and down starting from the center. The center's right here. So you're going to go up and you're going to go down, meaning you're only going to add and subtract to the y coordinate, right? You're not going to add and subtract to the x coordinate, right? That's why we have to identify your major and minor axis there, right? That's why I'm very specific about step 4. Be like, okay, let's reduce the amount of confusion there. Let's reduce the amount of confusion there. It says, okay, well, how do I know where to add and subtract by 3? Well, Evox, thank you for the follow. Appreciate that. How do I know, again, how do I know to add and subtract here by that y coordinate? Because I identified that the major axis here was the y axis. So I know I'm going to add and subtract that a by that y coordinate from my center. So that's the basis of my reasoning behind why I know that the major vertices are going to be calculated in that way. So I just take steps 2, 3, and 4. I set it up in a way where I'm not going to guess where those numbers are going to be added at the end of the day. And again, I have the little chart here as well here, Brian, that also will be helpful as well if you want to, take a look here and how, this is going to be consistent across the board. What kind of mental math calculations would you like to do? Like just addition, subtraction, just multiplication in your mind? Just basic stuff? One of the best ways that I learned when I was actually, I know this may seem a little bit weird. But when I was in kindergarten, one of the things that they made me do in kindergarten way back in the day was they gave me a sheet of like 100 questions. It was basic addition subtraction. And they asked me, okay, you have 1 minute to finish as many questions as you can. Oh, okay, no problem, right? So when I was given those 100 questions, they asked you, okay, you have 60 seconds to finish as many of those questions as you can. Now, realistically, you're not expected to finish all 100 questions. Okay, that's not the point. The point is for you to actually think through the questions really quickly, and then be able to improve your mental acuity with the amount of with just doing it as quickly as you can. These are like quick basic addition questions, and you can grab these sheets online. They're really easy to get. and print out and whatever. But you could do that with addition, subtraction, multiplication, and even division. And you can test yourself if you want to time yourself about how many problems you can do in a short amount of time. Repeat that process. Repeat that process every day, and you can just do it like once a day or twice a day just to kind of test yourself. And then start improving that kind of mental math calculations, and then just kind of build up from there. Start with the basics and work your way up. You'd be like, well, these are baby problems. I'd be like, yes. All right, 15 plus 8 is a super baby problem. But if you're doing mental math calculations and you want to do them quickly in your head, okay, it's a good place to start because at the very least you have the fundamentals down. And then maybe you test yourself a little bit further doing harder problems later on, like harder addition problems where it's going to take you a little bit more time to do that, like doing 85 plus 23. Okay, that's going to maybe take you a little bit more time to do. So, and you're like, okay, well, give yourself instead of 60 seconds, give yourself 2 minutes and the same 100 problems. And so you just kind of work your way up from there. And then your mental math calculations can be a little bit better over time. So it's not an instant process, obviously, but it's just a practice process. Start from the super basic and then just work your way up. And yeah, you do enough of those problems and do enough of those kind of little mini challenges for yourself. Yeah, your mental math gets to be pretty sharp. And then you can try even more advanced things after that. You know, I may teach this stuff all the time, so that keeps me mentally sharp, at least mathematically. But yeah, if you're just starting off with something kind of from the ground level, that's the way I would actually approach it. In all honesty, Evox. So hopefully that answers your question there. Okay. Yeah, no problem. It's not a yeah. Again, Rome wasn't built in a day, so I don't expect people to get stuff in a day. I don't like I'm teaching conic sections today. I don't expect people to get conic sections today. I mean, that's pretty hard. So that's why we go over this really slow, so that way it's not super overwhelming. So you take it at a pace that you're comfortable with, where at the end of the day you're just making positive progress. It doesn't have to be like progress that you have to be making instantly. Okay, people want like instantly now, but you have to understand that your body doesn't work in an instant now sort of thing. You may want that thing right now, and you're not going to necessarily get instant gratification when it comes to learning something. It's a process. It's always has been a process. So your body works the same way. It's a process. So all right, let's put down the minor vertices here then. Yeah. All right. All right. So for the minor vertices here, our b is 2. So again, our minor axis here is the x-axis. So again, we're going to take 1 minus 2, comma minus 3, and that's the y-coordinate there. And here we're going to take 1 plus 2, comma minus 3. All right. And so here we're going to get minus 1, comma minus 3. And here we get 3, comma minus 3. All right. Okay, so we get negative 1, comma negative 3. You get 3, comma minus 3. And those are going to be our minor vertices. Now let's go ahead and put the graph together. And we'll also find the foci associated with it. So here we go. We have 1, comma 0. All right. put these points down. Bad boys down here. Alright, first and foremost here. We have the point here, 1, 0. We have a -1, 93. Here we are. How does that look? Oh yeah, that's right. You check that here. 1, 0. Yeah, fine. 1, -6. Oh, 1, -6. Oh, I have that backwards. All right, Ming and Derp. All right. One, -6 is right here. Wonder why I'm like looking at this. I'm like, oh, why does this look a little off? Oh, well, that's why. Ha ha ha. I'm not smart. All right. There we go. That looks a lot better. All right. 3, -3. There we go. All right. Let's put this graph together here. Just really carefully. And if we go la 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 la. This is not the best looking thing you've ever seen. It's the extent of my artwork, okay? I'm a scientist, not a I'm a science guy, not an art guy. Art was never my thing. Yeah, this is the ellipse. Yeah, you're just gonna go with it. Roll with it, everybody. Roll with it. It's okay. Mine looks like an eye that works. It's better than what I'm ever gonna write put out. Womp womp. Yay yay. Okay. We did step 6 here, was actually graphing the thing. Now we could go ahead and find the foci here. Oh, this looks terrible. Alright. Okay, so what about the foci here? Again, the foci here uses the same exact formula here, uses the square root of a squared minus b squared. Again, nothing's going to change in terms of the formula here for c. Okay, so here we're going to get the square root of 3 squared. So we get 3 squared minus 2 squared. So if you do that out here really quickly, that's going to be equal to the square root of 5. That will be c. Now remember how it works here for here. Our major axis here is the y-axis. Now because this is the y-axis, we're going to start from the center. We're going to go up and down. Okay, up and down. We're going to add and subtract square root of 5 from the y-coordinate, starting from the center. So our foci here specifically is going to be 1, comma, -3 minus the square root of 5. And 1, comma, -3 plus the square root of 5. These are our foci here for this problem. Now, if I put, again, a decimal equivalent to this to kind of give ourselves a proper perspective, I get like -0.76, and I don't know, I could get minus root 5, minus 5.2. So, all right. So if you were to look at it from a perspective of, oh, you know, where would it be located in terms of a point? Again, it's located on the major axis. Here it would be like somewhere around here-ish, and somewhere around, let's say, here-ish. Okay, obviously it's not an exact science since it's on, you know, a whiteboard sort of idea. But there you go. That's where the foci are, again, inside the ellipse at the end of the day. All right. Any questions about that? Any questions at all about this example? Hopefully that makes this one pretty clear about how to get that done. Questions, questions, questions. Nope. Okay, great. Okay, so we're gonna yeah, we're doing another example here, La Serena, but it's a different example, different type of example. So we got one more example to do today. I figured I'd get through like 3 examples here because it just takes a lot of explanation for each one. So okay, so I'm gonna poof this one out of existence and gonna move on. Okay. Okay. Now, the next one here, I'm going to first go to our handout here for just a moment. So on our handout, I did put one other question here, number 4, and not that question, but number 4, how do we find equations of ellipses? Now we're going to use a little trick here. We found one method to find the equation of ellipse, again by dividing by 36 on, for all parts, and then we went ahead and solved for A and B and whatnot. Now, there are a few questions here that don't have that same kind of approach, unfortunately. And so what we're going to need to do here in those cases is we're going to need to use our good old friend completing the square twice to put these equations into standard form. Now I'm going to go through this problem here very carefully to show you exactly how we can go ahead and do that. Because you're like, completing the square? That kind of sucks. Like, yeah, I understand. But it has to be done in order for us to put it into our standard form of an ellipse that we're looking for here. So let's go ahead and do an example here. Just going to start off right away with an example. And going to showcase this off here as the last example for today. Alright, so which one do I want to do? No, not that one. That one kind of stinks. So I want to do one that just doesn't absolutely suck. So, alright, that's a classic one. Alright. Okay, here we go. Now we got it. So we got 4x squared plus 25y squared minus 24x plus 100y plus 36 is equal to 0. Now you're probably saying, oh my goodness, this is an ellipse? I'd be like, yeah, it is an ellipse, but it doesn't look like an ellipse right now. What it looks like is very intimidating. And I'm not going to lie, that is very true. All right, but how do we make this less intimidating and more look like the problems that we just did from before here today? That's what we're getting after. And that was what my tip there was. Basically, the trick behind this is to get it into the completing the square mode. Now I'm going to show you how to get it into that completing the square mode here, as we're kind of running out of time here, so I don't want to be like I don't want to go too fast, but at the same time, that's how it goes. Hey Gemma, how are you? I hope you're doing well. Hope you had a nice weekend, Gemma. All right. So the thing I want to do here first, actually, is if we're going to go down the path of completing the square, we're going to go ahead and subtract by 36 on both sides. All right. So if you remember with completing the square, I move all the numbers to one side and I move all the x's and y's to the other side. So that's essentially what I'm going to do here. I'm going to basically do this. I'm just going to group all the x guys together, group all the y guys together, and I'm going to move all the numbers here over to the other side. That's what we're going to do. Okay? All right? Oh, good. Well, I can tell already that you are in a happier mood compared to last week, and I'm very happy to see that. and that is a very good thing. So if you got good positive vibes there, Gemma, I'm very, very happy to hear that. All right. Let's take a look here on the right-hand side, or left-hand side, pardon me. And I'm just going to group the x guys together. So I'm going to have 4x squared minus 24x. I'm just going to shuffle the deck chairs around. Plus 25y squared plus 100y. But yeah, look, I'm just pointing it out here because I'm happy too, okay? I'm nothing against you. Absolutely lovely to see, though. All right, so here I got the x guys. I got 4x squared minus 24x. I just kind of grouped them together. I have 25y squared plus 100y. I just grouped them together. And I got the minus 36 sitting on the right-hand side. All right, so let's look at each individual group, okay? Let's just do that. Okay. All right. Now I'm going to factor a number out of each one. And that number is going to be the number in front of x squared. Or in front of y squared. So one of the things I want to take away from this is that, again, factor the number in front of x squared and factor the number in front of y squared. So I'm going to put this little warning symbol here. Guys. Factor out the coefficient Is your dog doing okay, Gemma? Of x squared and y squared. I hope so. Hopefully Peppers is. So I'm going to factor out 4 out of this. And that will leave me with x squared minus 6x. Alright. Bring down that plus. And I factor out a 25 out of this. And I get y squared plus 4y. You booked both your vaccines as well? Because, ooh, very nice. Oh, good, good. I'm very happy to hear the dog is good. I'm glad you booked your vaccines. I'm glad that they're starting to roll out for younger ones. That's good. Got mine. Oh man, it's been so long since I got mine. To be honest, got mine in like February, right? I have my wallet somewhere. Put my wallet. Yeah, got it back here. Yeah, and I got my vaccine card tucked away in here. My vaccine card. Oh no. What is this? What? Oh! Oh, I totally forgot to cash that check. Oh. I haven't done that. Yeah, so I got this in March. Here's my there's my vaccine card, everybody. Ooh. Got a yeah, vaccine card. Woo. All right. Vaccine card is nice. So I got mine in All right. Hopefully everybody else has gotten their vaccines. Hopefully, if you have, then good. If you haven't, then get some vaccines. Not too bad. All right. Any questions so far? Any questions so far? Yes, any questions so far? No? Yeah, you're still a little young there, Goldmash, to be fair. To be fair, it's still a little young, but that's okay. You guys will eventually get it. They're working on vaccines for kids down to 13, so it will be coming out. It'll be approved fairly soon. They're still in the trials. All right. So let's talk about what we're doing next. What we're doing next is we're doing completing the square. All right. So if we're completing the square here, let's talk about this next part here, ladies and gentlemen. This part here is incredibly important. Okay. So if we're doing this properly, we're going to take B here. We're going to complete the square 2 times. Okay. 2 times we're going to go ahead and complete the square. So if you notice here, our B value here for X is minus 6. We're going to take minus 6, divide that by 2. Quantity squared. All right. So we take minus 6 divided by 2 quantity squared. This is going to be minus 3 quantity squared, which is going to equal 9. Now remember where we put this 9 here when we're completing the square. Now we've done completing the square on 2 separate occasions already. But this 9 here is going to go right here. Okay, so again, if you're not sure where it goes, hey, it goes right there. But remember how completing the square works, ladies and gentlemen. Remember, if we add the plus 9 inside there, okay, how much should we add to the right-hand side here? Remember, we always have to compensate for what we add in. How much should I add to the right-hand side? So I added by 9 on the inside of those parentheses, right? How much should I add to the right-hand side? What do you guys think? How much should I add to the right-hand side here? This one's a pretty critical question, so I want to be sure that you guys understand what we're doing completing the square here. You should add 36. Okay, all right, Nicholas. Why should we add 36? I agree with you. But why is it 36? Okay, very good. That's correct, Nicholas. Right. So when we added 9 on the inside of those parentheses, we didn't just add 9. This was one of those things we talked about when we talked about completing the square. We didn't just add 9. We had the 4 here on the outside as well. So we actually added 4 times 9 here, which is 36. So we add 36 here on the outside. All right, so we have minus 36 plus 36. All right, so absolutely correct. Very nice job, Nicholas. That's right. That is correct. Now we want to go ahead and repeat this process here, by the way. I want to repeat this process here with the 4. So we're going to take that 4, that middle term of 4, 4y. Take 4 divided by 2. Square it. Go ahead and do, again, squared. So this equals 4. All right, so I'm going to add 4 on the inside here. All right, and how much should I add now? So I added 4 inside those parentheses for y. How much should I add out here to the right-hand side? How much did I actually add by? 100, that's right. All right, now we're getting places. Okay, so let's take stock in what we have. We have negative 36 plus 36 plus 100. Okay, well that's pretty simple to do. And if we also complete the square, we also know we would do the next step here, which is to factor. And in this case, because we did completing the square 2 times, we are also going to factor 2 times. Okay, that is what we want to do. So as is our want here, we'll go ahead and do that here. So let's set that up. So here we have 4. And if we go ahead and factor this out, we're going to get x minus 3 quantity squared. Again, no reason to guess what this factors to because it always factors to x plus whatever this number is on the inside of these parentheses after dividing by 2. So plus 25. Y plus 2 squared equals 100. Well, all right. Not too shabby. Not too shabby crabby. All right. All right. Now comes the next test here for this particular process. Can you guys tell me what would I do next? What should I do next? My goal is to get it into standard form so I can graph this ellipse. What would I do next, ladies and gentlemen? Okay, that's right, Brian. Exactly. That is exactly correct. Very good. Right? That's right, Nicholas. Exactly. We're going to divide by 100, just like we did the last example. Okay. My eyes weren't so bad. Alright. So we divide everything by 100. Alright. Okay. So if we do that there. Oh. Sorry about that. Oh my god. It's so hard to see on this monitor. Like, I wish I could just change this cursor around. If I can or not. Can I change? Maybe I can. Maybe I don't have time to figure it out. Alright. In any case. This is equal to x minus 3 squared over 25. This is a plus y plus 2 squared over 4. And this equals 1. Okay. That's what we have here for that. All right? And now we can proceed to do the rest of the problem here. All right? I ran out of time, so I'm just going to go through the rest of this problem here really quickly. Again, this is basically what we've effectively done here. Is we've effectively done all of step 1. Okay, so I know this is a long-winded process, but this is basically step 1. And then once you have it down to that portion, we go ahead and then find our respective values that we are looking for here to start putting this whole ellipse together. So this is step 1 here, just in a big old nutshell. Obviously a lot of work there, but once you have it in that form, it's exactly the same steps as we just talked about for the other 2 examples. So you would go through the process here, go through the motions. All right, the center here, as Brian has put out here, again, 3 comma minus 2 is correct. Okay, so 3 comma minus 2, that would be your center. Your third step here, again, for A and B, here respectively, you could write that out as x minus 3 quantity squared over 5 squared. And then plus y plus 2 squared over 2 squared 1. So again, your A here would be 5 and your B here would be 2. All right, step 4, your again, I know I'm going over this rather quickly. I'm again just running out of time here, so major axis here is going to be your x-axis, and then your minor axis will obviously be your y-axis. And you notice that the rest of the problem here is exactly the same. So again, nothing really much is happening, at least in terms of the process here. Step 5 is to find your major and minor vertices. So again, your major vertices Our major vertices here is on the x-axis, so we're going to add and subtract by 5 to the x-coordinate. The x-coordinate is going to be 3. We have 3 minus 5, comma, minus 2. And 3 plus 5, comma, minus 2. So I'm going to get here specifically bases in the way. Minus 2, comma, minus 2. And 8, comma, minus 2. Minor vertices here is going to be, again, 3, comma, minus 2. Was our 2, okay, minus 2. And 3, comma, minus 2 plus 2. Here we're going to get 3, comma, minus 4. And 3, comma, 0. Okay. There we go. You can go ahead and graph this out. Let's put this on a graph. We get, what's this? Negative 2, comma, negative 2. Okay. That's like right here. Get 1, 2, 3, 4, 5, 6, 7, 8. 8, comma, minus 2, which is right here. Get 3, comma, minus 4, so that's going to be right here. We get 3, comma, 0, which is right here. Like, connect the dots here. Alright, there we go. That is what that ellipse will look like here after putting those pieces there together. And then finally, I haven't forgotten the foci here, because that'll be required for these problems here for this homework for sure, and on the tests. The foci here, again, c is equal to the square root of a squared minus b squared. So what is that, 25 minus 4? It'll be the square root of 25 minus 4, which is equal to the, sorry I'm going a bit fast here, but square root of 21. Again, our major axis here is the x-axis. We're going to add and subtract the foci to the x-coordinate here. So our foci here are going to be, starting from our center, 3 minus the square root of 21, comma, minus 2, and 3 plus the square root of 20, comma, minus 2. And those are our foci there. I'll leave it to you to figure out if they're, it's not really necessary to put on the graph considering they're whatever decimals, but they're on the inside of the ellipse if you tried. Check them out. Okay, and so that is how we can go ahead and put those pieces together. Like I said, the rest of the problem there was pretty straightforward because it followed the same steps that we had just talked about here from before. Really, it was the first part about how to find and how to put it into standard form from an ugly looking mess to something that was a little bit more tangible was the more important part here for this process. Are there any questions about that? Any questions at all? Can I put the notes back up? Yeah. Yeah, I can, Joseph. Can you zoom out? Hmm? No problem. All right. Any questions? Any other questions? Sorry about the long delay there. Just want to be sure that everybody's got that down. Any questions you guys have? Any questions? Guys, let me know if you're sure or not. Hopefully that makes things a bit more clear. That was the last example that I had for today. Again, there's a lot going on, but again, hopefully that the process, you've seen 3 different types of problems, so hopefully that'll square things out in terms of how you can approach these types of conic sections. So try not to make it too hard. I'm trying to make it as easy as possible, but again, I want, again, each of these sections will take a day to do, but we can go through these slowly without too much trouble. You have to go to a meeting with the counselor for fall classes now. If I may give you a word of advice there, Khadija. If you have an institution you plan on transferring to post ECC, make sure you know what their requirements are, because those can change from semester to semester and academic year to academic year. So I always tell people, sometimes some people get not the greatest advice from counselors, and it's not completely the counselor's fault. It's just because you have like thousands of schools and you have to juggle between each school regarding what the transfer requirements are going to be. So the problem is that you have to, if you can't, one human being, it doesn't matter. One human being cannot figure out exactly what the transfer requirements are from school to school. It's a very almost nigh impossible. Even if you have a computer, it doesn't necessarily like update, from from one day to the next. So thing is that I've had students in the past to be given bad advice, and it's and it really sucks, and they waste time and they waste money. So I tell people, okay, if you're not sure and you know what your major is or whatever the case may be, then you ask the school that you want to be transferred to. You ask them, hey, what's an acceptable course? And some of them, you can talk to the registrar's office, and they'll say, hey, send me some unofficial or official transcripts, okay? And then they'll tell you, okay, this is accepted as transfer credit, this is accepted as transfer credit, this is accepted as transfer credit. Like, they'll literally tell you what's accepted as transfer credit, based on what they have in their system and what's acceptable. And then that way you have a good idea on the table about what credits you expect to get once you walk in the door, you know, and just keep asking them. If you have an expected date of graduation, just keep asking them, hey, is this accepted now? Is this accepted now? Because someday at some point, some department's going to have some meeting that says, you know what, I don't really like these requirements, and then suddenly everything changes because they don't suddenly like these requirements. I don't know why. Don't ask me, but it happens all the time. Okay, so even in math, it happens all the time. Oh, you didn't teach this particular topic at the end of the semester, so therefore it's no longer required. It's no longer applicable. It's like, but you didn't say that the semester before. It's like, well, we just changed it. Like, and then of course it's like, oh well, I'm screwed. So, you know, um, yeah, you have to kind of keep on your toes about it. I know Transferology is a pretty good website for that, but I always like say, hey, okay, a website can give you a source, a counselor is a source, but I said get it from the horse's mouth. Go get it directly. If you have a pool of schools, just ask each school individually and say, hey, tell me what's transferable based on my current transcript, because I don't know. I always tell them, hey, a counselor can only do so much, but you got to go out and see for yourself. So, because when you graduate, your associate's degree can take you far, but if you're just transferring just straight up credits, then yeah, you want to be sure you're not wasting your time and wasting your money. So that's the best advice that I can give everybody here regarding transfer stuff. It doesn't matter. Every semester it's always different. So I don't want I don't want people to end up screwed. That's the last thing I want. So I've seen it before and I don't want to see it. It's really, really brutal to watch. Like I've straight up just have people in tears, and it's just like that's not. It was an avoidable situation, and I'm like, just tell you, just gotta go out on your own, you know. Hey, Brianna, how are you? Good to see you. Hello. Yeah, I want to be sure that you guys are taken care of. Hey, look, Khadija, at the end of the day, I want to be sure that you're taken care of, okay? That you make sure that whatever advice you get from the counselors, you take it to heart, and then make sure that you take their advice to heart, but you actually take it to heart of the again the first-hand advice from the school that you're transferred to. If it happens to be NIU, make sure it says, okay, I'm going to NIU, fine, right? You go to ISU, you're like, okay, hey, um, tell me what I need. Good. Right. Any more questions or advice I can give you here? All right, Brian's out for the day. Very good. All right. All right. If there are no more questions or the like, that is perfectly fine. All right. All right. I would like to thank everybody for coming on out here to the stream once again. Thank you so much. Thank you. Thank you. Appreciate that. All right. I want to thank everybody for coming on out here to the stream once again. All of you are absolutely fantastic people. Okay. Absolutely fantastic people. Thank you so much. You guys make this incredible, enjoyable, the whole 9 yards. All right. Thank you very much. All right, everybody, we will come back tomorrow. We're going to continue on with conic sections here. It's section 7.2. All right. In the meantime, keep working on your tests. Keep working on those exams. But as always, everybody, stay safe, stay healthy, but most importantly, stay sane. All right. Have yourself a great one, everybody. Have a wonderful afternoon and evening. All right. All right. Take care of yourselves, everybody. And we will see you all later. All right. Have a great one, everyone. All right. See you tomorrow, everybody. Take care of yourselves. Bye. Bye, everybody.